Alrighty, we're going to start operations with radical expressions. I was going to do simplifying nth roots, but hey, that's part of this, so why bother doing something extra when I can just squeeze it onto here? Now, I am saying we're going to simplify radical expressions, and then we're going to add, subtract, multiply, and divide radical expressions. We'll do our best, and see if we can do that. We will for sure do... Oh, that looks interesting. We will sure do at least simplifying. And from multiplication and division standpoints. If I feel like these notes are getting too long, I will divide this here and just do the simplify, and then we'll come back to the other part. Anyways, moving forward. Okay, so keep in mind, we're going to look at like that. The opposite of an x squared is square root. Opposite of x cubed is third root. Opposite of x to the fourth root. So we're now going to deal with radicals. This symbol right here is called a radical that have different roots. Oh my God, I can barely handle square roots. Whatever shall I do? I don't know, but let's find out. Maybe I can help solve some of your problems with that. Let's go here. Let's keep in mind what I'm talking about here. You cannot no longer just think that a square root symbol is just a square root symbol. It's actually a radical symbol, and we will refer to them as radicals. That doesn't mean that they're kind of crazy numbers, or they're like, say, overly liberal, conservative, or something like that, or they want to start a revolution. It's just a term, okay? Go with it. The number under a radical is called a radicand, and then the number here is called, that's over the radical, or the radical sign symbol here, that's called an index. Now keep in mind that if you do not see any number there, then in this case you presume there's a 2 if there is no number there. In other words, it's a square root. There is no possibility for a radical with a power of 1. Oh, interesting. Yes, I think so too. Okay, so I'm going to use the factor tree method for this because, I mean, I can give you like cubes, squares, fourth roots, stuff like that. I think that's a little bit crazy. What that means is this. Numbers and variables are going to be grouped by the index. So keep in mind, like if it's the cube root, third root, that means I'm going to group them groups of 3. If it's the fourth root, I group them in groups of 4. The fifth root, I group them in groups of 5. Variable exponents can be divided by the index, but keep in mind that if there is a remainder, like it doesn't come out even, you need to be able to find that. You need to know how to find that. I have a tendency to write them out. It means writing them out a little bit more work, but it's not that difficult. Let's look at an example. All right, so this right here is the square root, because there is no number on the right and the index, square root of 32x to the 8. So that means I want these things in pairs. So like maybe you go 2 and 16. Okay, and then you go 16 is 4 and 4. Maybe you think that nicely. Yay! Okay, here's the deal. If you've got to pair something and you were looking for a pair, then you can stop there. And you could have said, okay, that's 4 square root of 2. But let's say you didn't think that and you said, oh, 4 is 2 and 2, another 4 is 2 and 2, and I'm looking at that. Well, guess what? Pair of 2s, you got a 4 on the outside and a 2 on the inside. Now, x to the 8th means I will split that up and I will start grouping them by pairs, but I'm going to write 8 x's. So how many pairs did I get? 1, 2, 3, 4. 4! Ha 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 ha! If y'all don't know Sesame Street, that was kind of a hint of that. Anyways, so this would be x to the 4th power. There was nothing left over, so there is nothing else under the radical symbol but that 2. So your final answer is 4x to the 4th square root of 2. Now, on this type of stuff, you will not have to worry about sign. You will not have to worry about putting plus and minus. Just go ahead and just give me the answer. So what happens if I don't, and yeah, you could have gone 8 divided by 2 is 4 and x to the 4th. But what happens if I don't come out even? Oh no, let's find an example where we can't. Alright, 12, let's see, 2 and 6, yay. 6, 2 and 3, yay. So what do I have a pair of? 2s. What do I have left over? 3. Ha ha ha. X to the 6, that's 3 pairs of x's. Notice, boom, 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 3 pairs of x's. X cubed is on the outside. Y cubed is 3 y's. That means I only have 1 pair that goes on the outside, and I have 1 left over that stays inside. Bam! Mind blown. So that's how I would simplify that. So those are how I could simplify square roots. What about something higher? Let's look at a cube root, shall we? We shall. Okay, cube root. Now I want them in groups of 3. So I start breaking up 27 to be 3 and 9, 3 and 3. And again, I'm looking at the ends. So I have one group of 3s. Probably should have chose a different number. Anyways, so I have one group of 3s. So that means I have a 3 on the outside. Nothing left on the inside for the cube root. Now I'm going to start putting my 12 y's together, but I'm going to write them in groups of 3s. So according to this, I have 4 groups of y's that are in groups of 3. So that means I would have on the outside y to the 4th. See, the number of groups you have is what would be on the outside for the exponent. Z7, I have 7 z's. Whoops. And then that would be, so you can see here, I organized them by 2 sets of 3's. So that would be z squared, but I have 1 z left over, and that would stay under the radical symbol. So my final answer is 3y4 z squared times the cube root of z. It's like, why so many letters? Because I can. Alright, so let's also notice here that on radicals, they cannot be in the denominator. You can never have radicals in the denominator. You must rationalize the denominator to eliminate the radical. So what does that mean? It means if you have something like this, x to the 6th, y to the 7th, and you simplify that, okay, so I would divide by 2, x cubed, nothing left over. You can see I'd have 3 pairs of x's, and y to the 7th would give me 3 pairs of y's with 1 y left over. I cannot leave that radical on the bottom. No square roots, no third roots, no fourth roots, no nothing. So how do I get rid of them? There's a process called rationalize the denominator, which means you're going to multiply to get rid of the radical on the bottom. The easiest way to do that is usually find a number that would simply eliminate the radical. In this case, if I have a square root, I just need to rewrite the number that's under the square root, put it top and bottom. The square roots would cancel each other out, leaving you just whatever's under that square root symbol, in this case y. So I'd have y cubed times y, which is y to the 4th power, on the denominator. And then on the numerator, I would be multiplying the x cubed times the y. But since I don't know the sign of x, I'm going to put absolute value. Now, if you forget that absolute value symbol, I'm not going to count off, but I'm just telling you this is something, because this is something kind of new that they've been adding in. I don't remember this even, say, a few years back. So I have the absolute value of x cubed times the square root of y. Nothing you can do with that, so you just put it together. The absolute value of x cubed times the square root of y. And you're done. So notice that there is no radical symbol on the denominator, on the bottom. Alright, let's look at another example. Same thing, square root. I've got a to the 9th, so I'm going to write 9a's. There's 4 groups, that's a to the 4th, with an a still left in the square root. Now I'm going to write 5 b's, boom, boom, boom. So I have b squared with a b left over. So what can I not allow? I cannot allow the square root of b. So I'm going to multiply both top and bottom by square root of b to get rid of that square root. By doing that, again, the square roots cancel each other out, leaving you whatever's under there. So just the b. And then I would multiply by that to the bottom. B squared times b would be b cubed. Notice it just increased it by 1. I have times a to the 4th times a times b. Now, if there's 2 things under a radical symbol, they can multiply each other. But if there's something outside, it cannot multiply something inside. This is no distributive property. So a times b is ab. And that is my final answer. Boop, boom, boom. There you go. Notice I did put the absolute value sign. No big deal. Alright, let's do one more example. And like I said, I will split this up. So there will be another set of notes, say Monday, to discuss the adding, subtracting, and the real multiplication and division. So let's look at one that has a 4th root. There's that 4th root. So right now I'm saying the 4th root of 6 and the 4th root of 5x. Notice how I split those up and put them as separate radical symbols. Again, I cannot have a 4th root of 5x. So what do? There's nothing I can do with these as far as the numbers themselves. So what do I need to do? I need to multiply to get rid of the 4th root. Now, to get rid of a 4th root, that means I have to have like 4 5s. They would have to occur in groups of 4. Like it would be 5, 5, 5, 5 to get something that goes out. I only have 1 5 right now, so that means I need 3 more. So I'll put 5, cubed. That's 3 more 5s. I only have 1 x, so I'm going to put 3 more x's. So that way I'll have 4. Because when I multiply those together, I'm getting 5 times 5 cubed is 5 to the 4th power. X times x cubed is x to the 4th power. Basically, how many 5s and how many x's do I have? And when I take the 4th root of that, I'm just left with a 5 and an x. Because I had one group of 5s, and now I have one group of x's. That's the worst looking x's ever. And that's why it's 5x. Now I got to do that on top also. Now again, I can multiply 6 times 5 cubed. I can't do anything with the x cubed. 6 times 5 cubed, if you type that in your calculator, it would give you 750. 125 times, 750 x cubed. Notice I didn't need to do something in that second to last step. But there you go. And that's it. That's as simple as it gets there, folks. That's all it is. So that's it for today. Make sure you have these for me the next day or the next time I see y'all. Y'all take care, and thank you for listening.